Our next speaker, which will actually be the final speaker before we take a 15-minute break, are Colonel Stoney Trent, who will be giving a keynote and updating us on using AI to transform and secure the DoD. Colonel Stoney Trent is a PhD from the Army Cyber Warfare Officer and Cognitive Engineer, currently serving as the Chief of Missions for the Joint Artificial Intelligence Center under the Department of Defense Chief Information Officer. Previously, he established and directed the U.S. Army Cyber Command's Immersion Lab, which develops and assesses capabilities for the Cyber Mission Force. He served as a Strategic Policy Research Fellow with the Rand Arroyo Center and is a graduate of the Army War College and former Cyber Fellow at the National Security Agency. So please help me in welcoming my friend, Colonel Stoney Trent.
Thanks, Paul. Can you hear it? This is working now, right? Okay, great. Thank you for your time and attention today. Parham, thanks for the opportunity to come and share a little bit of an update on what we're doing at the Joint AI Center. Really a good sequence of speakers here that kind of teed up some concepts that I'll just build on. Starting with Mr. Hagley's discussion on our cybersecurity priorities in the DoD. What I'll be sharing with you is how the Joint AI Center is tackling a breadth of issues across our warfighting and support functions, and then a little more detailed discussion on how we're focusing one of our missions on those cyber priorities. There we go. Great. Some of you, show of hands, how many of you already have heard about the Joint AI Center in some form? Good. So we're successful. We're socializing that we've been a thing for about 14 months now. July of last year, I showed up to the DoD CIO, and they said, "Let's stand up this thing." And they gave me a closet in the Pentagon, and we started to work. We're over about 150 persons today, between FY18 and 19. Budget of about $340 million, and we're expecting to extend our growth, in the Defense Department over the upcoming 4 to 5 years. This chart here that you see is a popular one we like to share. It kind of gives Mr. Deasy's concept, the DoD CIO, his concept for and vision for the JAIC as an AI center of excellence, as a transformation agent in the world's largest bureaucracy. This is not a small mission, obviously. We're not just a startup. We're a startup of startups within this tremendous organization. As such, Mr. Deasy's vision for the DoD AI Center of Excellence is it serves as a flywheel of AI expertise within the Defense Department. So it's not just a schoolhouse. It's not just a collection of wise men that are sprinkling fairy dust and espousing wisdom. It's an organization that delivers technology while also interacting and forming policies that help us reduce both non-technology barriers as well as technology barriers. And I'll share some insights over the last 14 months of standing the organization up with you. Particularly for those of you that are thinking or are part of large organizations that may see the desire to modernize some of these considerations may apply to you as well. On the top part of this chart illustrates the people side of the JAIC. As a cognitive engineer, I bring the gospel of humans and users to the AI technology delivery process here. Delivering artificial intelligence is inherently data and computer science, but it's not only computer and data science. In fact, you'll get very shallow, brittle implementations if it's entirely led by computer and data scientists. That's a really important talking point. I want to emphasize that I former West Point professor, and I teach middle school and high school students in cybersecurity club up in Bethesda. And I want to encourage you all to take notes because there's a lot of good material I'm going to share with you. That's one of the key points that I want to share is that this is an interdisciplinary activity. One of our our cornerstones for product delivery in the Joint AI Center is that our product managers are domain practitioners. They're not technologists. So I'll say that again. Our product managers in the JAIC are domain practitioners. They're for a cyber mission, they're cyber practitioners. for a health mission. I literally have a thoracic surgeon that in the weekends does heart transplants leading our health mission. Or we have logisticians leading our predictive maintenance and logistics efforts, and so on and so forth. We have 6 of these missions that are aligned with our warfighting and support functions, and they're led by people that have a career's worth of experience in that domain. We're wrapping them with interdisciplinary engineers to ensure that they deliver good products effectively. But bridging research and operations requires this intimate knowledge of practice. In show of hands, how many of you have exposure to commercial software development? We've worked commercial software development, so you understand in some organizations what a product manager is responsible for. You'll know that that product managers are responsible for taking something from concept through sustainment. And in commercial software development, I'm building a web utility, or I'm building a search engine, or I'm building an app for an iPhone. The product managers can reasonably be presumed to have a good mental model of the user, their needs, to take a product through that life cycle. Well, for military applications, that work domain, the data, the conditions that the work is executed are generally inaccessible to most technologists, most people that have not had experience in those domains. And so we're mitigating that risk by putting those domain practitioners in charge of our product delivery. Bottom side of this illustrates the technology side of the JAIC. Our center of gravity is a dev test environment hosted on a cloud environment that provides not only the JAIC's mission teams, but also the Defense Department wide access to AI development and testing tools and applications. It provides all the secure infrastructure that others don't really want to have to build and sustain. And so this is one of the principal reasons why we're under the CIO and not a research and activity. We're not a research activity, we're bridging research and practice. I mentioned our 6 missions that are delivering human-centered AI. And this is again, going back to what I believe is my principal responsibility in the AI Center, is to ensure that we're actually doing that, not just putting a label on bad technology as human-centered. That would be a disaster. Each of these 6 missions is aligned with one of our major communities of interest. What you can start to appreciate is, if we're going to deliver transformation in the Defense Department, that we'll have to transform not one of these communities, but all of them. Right? It's not only that I have a Project Maven working on an Intel project and we're showing great progress in computer vision for Intel analysts. It's also that we have to be able to support health administrators and health logisticians and people performing command and control. And we have to make them equally knowledgeable of the value propositions of AI so that they can understand how to be a part of the transformation. We're not just delivering widgets to communities. We have this other responsibility of not only providing impactful technologies that users like, but in the Defense Department, most of you are familiar that the Defense Department doesn't just have users don't buy anything, right? This is not like commercial software sales. Number of people that buy my product off an app store is not a measure of success for military systems. The people that buy our products, or your products if you're building things for the Defense Department, are program managers that will likely never use those products. And so we as a bridge between research, whether that's government or commercial research and practice, have to create this 3-legged triangle of us, vendors, the users, but also those program offices. So that's 4 legs. The cyber mission in particular, I'll spend the rest of my time discussing this as an example of the way the other missions are operating. As the Chief of Missions, my role is to ensure that we're identifying impactful product lines aligned with real operational use cases to which we can apply mature AI approaches to offer meaningful impact within 6 to 12, maybe 24 at the longest lifespan. It is collaborative prototyping in collaboration with those groups that I just described. The cyber mission is illustrative of the others. Many of you are familiar with the problems that I've described on the top of this slide, so I won't repeat them. They're probably very familiar to you, especially if you work with big companies as well. Our goals nest with those that Mr. Hagley described for our cybersecurity objectives, the DoD CIO. It's not a coincidence because my boss's boss is his boss too, right? So a couple of key points here are that we're not only seeking to reduce cybersecurity risks, but also enabling cyberspace operations. This is a threat-oriented operation that is unique to the military. We're also see the need to demonstrate with our missions in particular the ability to cross-queue between agencies of the government and possibly with other sectors in commercial space. This means that we seek to deliver technologies that allow one agency to see something and share that information in a meaningful way with another. And at the bottom of this, of one of our cyber mission goals there is critical for most of you to note that we understand the importance of leveraging the billions of investments in AI for cyberspace that's in the commercial arena. What we have to become effective at, very efficient at, is doing that in a helpful way. And I'll talk about how we intend to do that with the cyber mission. This is an operating concept that we're demonstrating in the cyber mission that shows that, at the top of this you may see, okay, this is project management. But what's enabling this efficient product or project management, and I encourage you to think of this for your projects that support military applications, is what I consider a campaign of field study. All right, this campaign ensures that our product managers have consistent access to users, have an ongoing dialogue with program officers that ensures that by the time we've completed it, some spiral investment, some amount of prototyping, some amount of operational testing, that it's a seamless transition into one of those program managers' kit bags, that they have the funds set aside for it, that their prime vendors are able to integrate the solution. Otherwise, we've really just wasted yet more taxpayer dollars. That campaign does a lot of things for us. It not only helps us do those things, but it also allows us to elucidate new projects, new use cases that have operational relevance. It allows us to sustain a dialogue with our senior-most advocates in the cyber community, which are, for instance, General Nakasone at Cyber Command, his component commanders, those 3- and 4-star leaders, the sixes of the service components that need to understand how we're attempting to solve their problems in a way that's complementary to the deliberate capability development processes that they already are familiar with. So you'll see that this campaign of field study, as this illustrates, is executed by a cross-functional team of interdisciplinary engineers. It's led by people that understand how to ask meaningful questions of people. But it's supported by data scientists to be able to unpack and inspect data, to understand what is in the realm of possible for an AI implementation before you get started. Not surprised by later, and we've had those surprises in the first year because we hadn't necessarily fully implemented this concept. So you'll see that this concept here is an element that we're using to support these 4 product lines. And some of you that have seen an earlier brief here a few months ago, we may have heard about our first 3 product lines. We've added another as a result of that particular engagement with our users and our program offices. So our focus for getting started with AI and cyber is just to get started in AI and cyber. It's not to solve the largest problems in the Defense Department. It's to start on tractable use cases to which we can apply and apply AI. And in the process of trying to do so, we understand the variety of technology and non-technology barriers that are in front of us. We're looking at network incident detection, moving beyond signature-based detection to being able to deliver models that allow us to identify novel incidents. User activity monitoring, being able to fingerprint user behaviors to detect misused user accounts before we've had an incident. Today, this isn't necessarily possible in the military. It's usually done forensically or very manually intensive. And then network mapping is an activity that is unique from the cyber security functions, network mapping functions that you might have exposure to with network operations centers. This is a threat-oriented support to our offensive and defensive cyberspace operations teams that have to leverage what are oftentimes under-skilled new practitioners. They're new cyber operators. They may only have a handful of months of experience in order, and they also need to operate in a highly efficient way that allows them to avoid detection by adversaries. Either those adversaries may already be advanced persistent threats in our networks, or they might be adversaries on their own networks that we're attempting to infiltrate. So an AI implementation that allows for inferences based on partial network data, that allows for expert handrails for junior analysts to become to be able to operate as experts is what we're seeking here. This is an interesting product line because the first two are very much commercial product evaluations. You have seen, I'm sure, if you've done market research from your foxholes, you've seen lots of commercial investments in those first two, and this is one of the reasons why we're starting with them. The third one is a government solution that we're seeking to create within which we're seeking to create an AI marketplace to allow multiple tens or hundreds of AI companies to come in and have access to data that's usable by these groups and deliver AI implementations that allow us to recognize unforeseen new capabilities. The last one is a recently started effort that stems from an operating concept that we're working on with U.S. Cyber Command, which I think generalizes. I'm actually preaching this gospel to our other mission spaces as well, or other domains. Is that right now? And I'm sure you and your colleagues may think of this in a way. Data is merely something that helps you accomplish, a particular cyber task. I use data in order to queue my incident detection system or intrusion detection system. I collect data in order to run audits. It's thought of as a means to an end. And it is definitely this case for cyber practitioners. Another way, a stronger way of thinking about this, because that sort of narrow-minded view of data doesn't encourage you to retain data and curate data, label data in a healthy way that allows you to use it over time. And so we've seen in this through this mission and our other missions a lack of global incentivization for treatment of data as a weapon system or as a weapon, right? In the military, we treat our weapon systems very specially, right? We inventory them, we care for them, we fully understand what they're capable of doing and not doing. We advertise that broadly. We train people on using them, and we don't do any of that with data. Data is relegated to, that's the data officer. We created a data officer. That's the guy. That's that person's responsibility. And so what we're encouraging with this product line, along with Cyber Command's concept of an analytic support officer, is taking practitioners in this case the cyber domain. In other domains, it would be other practitioners, a rifleman or a fighter pilot or a surgeon, and giving them some increased knowledge about data engineering and tools that allow them to inspect, curate, label, and inspect and share their data with data scientists and others in a way that allows us to actually leverage AI. I think this is a really critical concept. It in and itself is not AI, it's preparation for AI. And it's one of the things that we've learned as a result of exposure to data from our, what I call 24 pirate ships, our cybersecurity service providers. I call them pirate ships because they're kind of like, they operate on the local incentives. They organize individually. They have different tools. They have different roles. But they're all responsible for generally kind of the same tasks. They're just doing it in a lot of different ways. Each of these 24 cybersecurity service providers collect data differently, share data differently, have different notions of what aggregation risks might be. And what that's resulted in is lakes of data that are collected, missed opportunities for data collection, that allow us to really zero opportunities for AI implementation. So we're going to have to solve that from the DoD CIO's perspective, and I'll talk about a way that we're going to work on that. We've also recognized that through extensive market research and an intimate exposure to commercial cybersecurity products, that they're not all well suited for military purposes. Oftentimes, they're not actually engineered for cybersecurity themselves. They actually create more cybersecurity vulnerabilities than they solve. That's a tremendous problem. That technologists, narrowly focused technologists, and especially startups in Silicon Valley, often don't appreciate. Because to them, building in all this cybersecurity is just a business risk. I love the notion that we're working towards with the CMMC is to audit companies for cybersecurity measures. But in many ways, the government, the military in particular, has this responsibility to audit particular tools and vendors that are creating tools for us to use. We can't only get really efficient at bringing in and buying things from commercial investments, but we also have to get really good at educating them about the minimal viable cybersecurity provisions that are necessary. And so this is one of the things that we're doing with this. So because that's a part of getting things through this authority to operate, getting them onto approved products list, this risk management framework that's important. Startups see the risk management framework, and I know this because I've talked about 20 big and small companies over the last 6 months. They see this as just arduous. They're like, we don't understand it. It's opaque. How can we possibly work with the government? We don't even want to work with them. I'd say, well, actually what you're really doing is you're just trading easy customers for, hard customer for easy customers. You're willing to go and sell your poorly designed products to companies that don't have the cybersecurity expertise to inspect your products well. And shame on you. Shame on you. Shame on the government, though, for not making it more clear about what is minimally necessary for cyber security engineering. Shame on us. We have a responsibility to the nation to communicate those minimal standards. That should be just like an underwriting lab sticker that goes on my plug-in. I'm not going to stick this unsafe plug into my receptacle because I'm going to start a fire. I can intuit the risk there. People can't genuinely intuit the risks associated with bad cybersecurity engineering. So again, going back to why I like the scorecard for the CMMC. So I wanted to highlight for you, as I really am pretty limited in time, but I have a lot for you to take notes on here still. Barriers to AI adoption are the focus for the Joint AI Center. The reason we're delivering products is to recognize and reduce these barriers, and they're non-technology as well as technology. And I know that my AI engineers out there hate me when I say that, but the non-technology side of this slide is harder. It's bigger, especially in an organization like the military where we have $1 trillion of legacy systems. I'm not going to discard that $1 trillion of legacy systems just to reinvent everything to make it AI ready. I have to understand how to find the fissures in those systems to create transformational change in there. So on the left-hand side, you'll note the number one barrier to getting started is data access and quality. I've kind of highlighted some of that with you with the CSSPs. These problems generalize to our other missions, not just our cyber. Dev test environment, we're solving that. We hope to reduce that with our joint common foundation that I mentioned at the beginning of this talk. I talked about our legacy systems. Testing tools and methods are interesting because, again, in my discussions with industry, oftentimes the AI companies, the software dev companies of the world view testing as a business risk. Like, well, if I stop to test the way you guys want me to test things, I'm just going to slow to market. I'm going to be slow to market. And really my only measure of effectiveness is how many sales I have, and you're just going to slow me down and someone's going to beat me. Well, that might be the case if you're selling products to my daughter and son, But if you're selling products that have to work in scenarios of national consequence, if you're selling products that have to be trustworthy to people that have to make split-second decisions of national existential crises, we have to understand how they're going to succeed or fail. And so I encourage you and your colleagues to invest in testing tools and methods, to understand how AI is inherently brittle, or how any AI implementation is brittle, because they all are. Humans are the center of resilience, and I'm going to talk about that in my next slide, resilience when I talk about resilient systems engineering. On the right-hand side, I'll leave you with these. Some of these are self-explanatory. They're policy issues that include intellectual property and human capital. How do I leverage people that may have a data science background on actual data science problems in the government? That's actually not an easy thing to do if you're familiar with the way the government handles human capital. How do I educate people about what AI can and cannot do? I spend most of my time talking about what AI cannot do. I feel like that's important because we have, every day we drive in, we hear some commercial about what AI can do. And this is part of my personal crusade on this, is to remind people that human-centered engineering is the same as resilient systems engineering. It is, because the humans in systems are the principal source of resilience. If you believe that you've engineered resilience into the software code, you're fooling yourself about the future states that software are going to encounter. And you're relegating all of the resilience to whatever the designer, the developer, could envision when he or she was writing that code. So if you don't design for the human to become and be and stay the source of resilience, you've designed inherently brittle systems. It doesn't matter how fast things are happening. It doesn't matter that cyber packets are going at light speed. All of that's irrelevant if you haven't engineered for supervisory control that includes humans being able to monitor and redirect that system in efficient ways. So the terminology that I've found that that AI engineers and evangelists use, I think, are oftentimes misleading and unhelpful for us to understand what these software are actually doing. When you talk about AI learning and perceiving and computers paying attention, that is not. They're not actually doing that. Okay, that's an abomination of common language by a computer scientist to mislead or mischaracterize what that software is actually doing. Nobody that gives a toy to a child and expects them to learn about how to play with that toy thinks of it as them as making adjustments to coefficients in an algorithm somewhere, right? That's only going to allow them to make better sense of that particular tool that's in front of them. So that's not learning. That is model tuning, right? So these are mathematical tricks that are being conveyed to you as if they're psychological phenomenon. And that's a problem for us. That's a problem for us interpreting how the systems are going to succeed or fail. What often happens then is that AI implementations are made on the wrong problems. I'm going to solve this problem because the data is available for it, and I'm going to ignore these other ones that are probably even more important, but I just couldn't get to there. And so this is another problem. I actually really like some of this material I actually pillaged from colleagues that were actually supported under DARPA's Explainable AI program. They have a really brilliant report. I hope it becomes releasable that summarizes the last 30 to 40 years of successes and failures relative to artificial intelligence. And it all comes back to just people seeking shallow systems engineering solutions and ignoring the basics of human-centered engineering. Talking about things like, well, because this domain happens so fast, because cyber happens so fast, we need to replace people with these things. In fact, that never happens. People are never replaced. Our roles change. Our expertise that is required to manage those technologies change. If the people that were at DARPA, ARPA lab, that were inventing the internet would have foreseen the career field of cybersecurity professionals that was going to emerge by them creating, packet switching, they probably would have stopped. They were like, my goodness, what are we going to create? This is going to be a disaster. We'll have created more problems than we solved. And I don't say that as a bad thing. I say it as a thing that we need to understand. That these technologies are not simply going to replace people. They're going to change the nature of work. They're going to change the nature of interactions, and we need to design to accommodate that. Really brilliant book written by Dave Woods highlights these sort of fundamentals of systems engineering, that you have to design good technologies to be observable, directable, that direct users' attention to areas of interest before there's a problem. Brilliant use cases in the design of cockpits for airplane cockpits, where we thought we could design it. We removed this is called a glass cockpit model. We were going to move to where nothing really was visible because things were in the airplane were going to happen so fast that pilots couldn't understand it. They were going to be relegated to sort of feeding the dog that was pushing the button that was flying the plane. What we found is when we engineered out that feedback system to the users to the human stakeholder, the principal source of resilience, the plane did all sorts of things to try to correct and fly stably until the point that it couldn't cope anymore, and it said, I give up, pilot, you're in charge, take over. You have no idea what I did up until now. I'm sorry, I'm done. I've reached the limits of my software. So that can't happen with cyber tools. It can't happen with good systems in any work domain. We have to understand how we accommodate good feedback for those users throughout. This requires upfront investments in cognitive work analyses to understand how to frame use cases, how to frame user experiences, how to frame other artifacts to align product development. In commercial software development, we can accept a lot of risk because I'm just building a Candy Crush app and someone's going to like it or not like it. Pokemon Go succeeds or does not succeed based on numbers of users. Military systems, that's not the case. I've already highlighted the importance of testing tools and methods, so I'll go back to one point here about problem scoping, give a little vignette about this. From our predictive maintenance product line. We have a predictive maintenance mission that's looking at how do we apply AI to improve readiness and reduce costs of H-60s, helicopters, the Black Hawks. They're operated by Alpha Services. We went out initially and said, well, listen, we found this joint platform, the H-60. There's one particular component on it that's highly instrumented. It's the engine. It's really expensive component, $750,000 component in this system. If we can, and we found that units are pulling data off of that device that we might be able to use to train models to predict engine health or something like this. And we asked the maintainers, what are your biggest problems? What can we help solve with AI? Well, the cognitive engineers will tell you that's the worst question to ask, because practitioners generally will answer that question wrong 99% of the time. In this case, they said, well, our biggest problem is glass over in the engine. We fly through sandy environments, the sand accumulates in the turbines, it turns to glass, creates low power conditions, and planes don't fly in those conditions. Can you write an algorithm, can you train a model to help us identify glass over conditions in these engines? The data scientists on the team said, absolutely, I can envision a world in which a model will do just that. You give me your data and I'll take it back to my lab in a couple of months, I'll have that trained. And I'll give you something that predicts this state. Well, after inspecting the data, you realize that the helicopters aren't falling out of the sky because of glass over conditions. We never allow them to get to that condition. So is that condition ever in the data set? No, it's not. So in fact, you'll never be able to predict that state. That failure mode does not exist in the data. You've been scoping the problem in the wrong way. And you've wasted time and you've wasted money. And so this goes back to my earlier concept sketch that shows this spiral. It kind of looked like it was a waterfall, but it was not. It was showing multiple product lines all functioning in a spiral development manner that operated closely in conjunction with users to identify what their data actually even includes in it and what problems are operationally meaningful for them. I'm going to close here with the last slide because this is an important one. I've heard the panel here was smart. I like their comments about sharing their successes. I believe we've achieved a great number of successes even in the first 14 months. The growth and budget are not those. It's that we are now we have a website. We have AI.mil. So feel free to visit us on AI.mil. It's some good terrain there for you to consider, easy to remember. It is an acknowledgement that we understand the importance of strategic communications about our successes and failures. That we have a responsibility in the Defense Department, if we're going to transform the Defense Department, to be able to be transparent with the department and with commercial industry. A change agent in the Defense Department can only change the department if it's a part of it enough to change it, but apart from it enough to be a part of the technology sector, the commercial sector, that allows us to leverage goodness. And so this website is just one example. I thank you for your opportunity, your interest and attention today. I encourage you to push ideas to me. I've never been to one of these forums where I haven't gotten great ideas from the participants in the audience, and so thank you for your time and attention.